I'm Bryan DeLuca, and I am here with Chris Burket at the TDK booth at APEC 2025. Chris, what do you got going on?
Okay, Bryan. So first of all, nice to meet you.
You too.
So I've been involved in wireless power technology for about 15 years.
Okay.
And when we first started, it was the the WPC Wireless Power Consortium. They were more focused on working with cell phones. That was the market they were going after.
Right.
So for many years, it was just these planar type coils that would then allow you a little bit of spatial freedom that you could drop your phone on and it would charge. But things changed when the iPhone 12 came out with permanent magnets inside.
Right.
So that MagSafe technology. So that permanent magnet has a permanent DC flux that saturated the RX coils.
Okay.
So it made charging very, very difficult. In fact, if you don't have a thick enough magnetic shield, your phone won't charge. Right. So we're going to start off with a standard. This is going to be the Qi 2 standard, so it's an MPP plus EPP.
Okay.
So the MPP is the MagSafe equivalent within the Qi standard, and then the EPP is the extended power profile up to 15 watts.
Okay.
Okay, so iPhone. So if I come in, it will just do regular charging off the EPP. But I can show you that I can isolate the MPP, and I can come in, and now it will charge with the MPP standard.
Gotcha.
Right. The system will have intelligence, so it will do it by itself. It will pick up which technology to use because they operate at different frequencies. So you can't use those same coil for both without switching frequencies or whatever.
Gotcha.
But in a real system, it will do it automatically. It will say, hey, I've identified that it's an iPhone or somebody else's phone, and then it will tell you which technology you need to use. So done automatically.
So what do engineers need to know about designing stuff like this into their systems?
It's not as trivial as people think. There's a lot of complexities in it that, again, you're operating at different frequencies. And due to that, you have different inductances.
Right.
And that those permanent magnets that are in the system, as I said, will pre-saturate the RX side. So you want to make sure that now, instead of just focusing on the TX side, you also got to start looking at the RX side as well. Right? So it's a system problem, not isolated to the TX side.
What do you picture as the next evolution of wireless charging?
Oh, well, higher power, into the tab. We've been working with tablets for years,
Right.
but now they want to go to the 65, 95 watt type of thing, and you've got EMI issues to work with. You've got the agency or regulatory compliances to work with, and you got thermal issues that you have to deal with. Right? You're never going to be as efficient as plugging in a wire. But you're trying to make it as convenient as for people as possible, so you don't have to plug in. But one of the biggest complaints I hear right now is that when they have their phone on the charger, they pick it up, it's warm. Yeah. Right? And that's part of the efficiency, because the load of the RX side is never going to change. So if the efficiency is low, the TX side has to work harder. It has to pump more current to get a better or a stronger magnetic field in order to bridge that air gap. So that's the challenges, getting higher power but maintaining the thermals. So as I said, Qi standard, the WPC focused on phones at first.
Right.
But there's all these other products that they want to put wireless charging in. So this is a golf ball demo. I've worked on 2 golf ball designs. So they want to put sensors in it to know whether what your speed is at impact, when you hit the ball, whether you're coming at an angle so you'll slice or hook. So there's sensors being put into cricket balls, into baseball bats, into golf balls.
Into everything.
Then we've worked with multiple stylus companies.
Okay.
And so this is like electronic pens, just to simulate that, hey, you can do like whiteboard electronic pens and we can do the charging for them.
So you're looking at charging also things that don't have connectors.
Connectors or not flat.
Right.
Which is the real challenge.
Right, like this, because it has to be in the correct place.
Exactly.
To charge. So how is this actually making
contact? So we actually put the coil around the inside.
Gotcha.
And then we have a matching coil in the inside of the ball.
Okay.
So it's an inductive system, but it acts like it's resonant. Okay. So orientation is not important, alignment's not important, distance is not quite as important. So then you get into like hearing aids. So the elderly, like me, you can edit that out if you want. The elderly, like me,
we may not.
we can't hear and we can't see, right? So right now, I call it a micro toaster. They have to take their hearing aids and put it into these little slots, and then they make sure that they're making contact. But if you've got dirt and grime or oils on them, they're never going to make contact. So we came up with an approach, a technology that you could just toss them into the bowl. You always know where they're at. They're always being charged, and you can do multiple devices at the same time.
Right. And I think one of the important things you mentioned here is the orientation. Like with the phone, you got to lay it flat. It has to be perfectly aligned.
Exactly.
With these, it almost doesn't matter where it is,
Okay.
which
Okay,
is huge.
so I've done a lot of designs. I was on 5 Fossil watch models. I was on only devices. I worked with Intel on a watch design. And the thing is that every time we designed the RX that would go into the watch, you had to design a mating or a matching transmit coil.
Yeah.
So it was one project, but I had to do 2 designs.
Uh-huh.
So I was playing air hockey with my daughters, and this like an air hockey paddle, and I said I could do something with that. So if you have a smartwatch, say you have a fitness bracelet, and say you have like a glucose monitoring device, we can charge them all at the same time, and not have to worry about, again, orientation, proximity, and things like that.
That's really cool. That's really cool.
So we're doing it with some medical devices. There's more than just these. We're doing it with smart glasses. We're on a project right now.
Right, you just drop them on the tray.
Drop them on.
Yeah.
Awesome.
That's really cool. This is impressive. This is impressive.
All right.
Well, Chris, thank you for your time.
Thank you.
I appreciate it.
Come back. Thank you.